Okay, the next question is find the quotient and remainder when a cube plus a square plus 1 is divided by a plus 1. Okay, now one way in which you can solve this question is regular division, जो हमने शायद स्कूल में सीखा था. If not, we'll just again go through it step by step. So I'm dividing a cube plus a square plus 1 with a plus 1. Okay, अब मुझे यहाँ पे a cube का टर्म चाहिए, but मेरे पास यहाँ पे a है, which is a raised to 1, right? So very logically I need to multiply it by a square, isn't it? So when I multiply this term with a square, actually both the terms get multiplied by a square, right? So a square into a is a cube, the first term. A square into 1 is a square, the second term. Okay. So now the rule of division, we now subtract the terms obtained. When you subtract the terms, they get cancelled out. We only get the remainder as 1. Okay. So very clearly you can observe the quotient is a square and the remainder is equal to 1. Okay. एक और तरीका था guys, which we have learned in school anyway, and that was called as synthetic division. Okay, when we are not actually dividing all the terms, okay, we are just dealing with the coefficients of the terms. Okay, so a cube plus a square plus 1, it's actually 1a cube plus 1a square plus 0 a raised to 1 plus 1 a raised to 0, right? I'm just writing the coefficients of all the terms here. Okay, so I'll just put down the coefficients 1, 1, 0 and 1. Okay, now guys, the synthetic division is only applicable for terms, okay, when the dividend is basically of the form x raised to n plus something, and the divisor is of the form x plus or minus a. Only then this will work. Okay, but this division works every time, no issues. Okay, anyway, but synthetic division, we are seeing it right now, will work only for these cases. Okay, so we now observe a plus 1 जो कि अपना divisor है, a plus 1 0 कब होता है? When a is equal to minus 1, right? So we'll divide all the coefficients by minus 1. Okay, the first step is to carry this 1 down. Okay, when you do that, you get the 1 here. This 1 you multiply with minus 1. Okay, this 1 you multiply with minus 1 here. Okay, 1 into minus 1 is nothing but minus 1. You write it here. Okay, you add these two now. You add these two terms. Okay, you get a 0. Now 0 into minus 1 is again 0. You add a 0 here. 0 plus 0 is 0 here. Again 0 into minus 1 will give you 0 over here. 1 plus 0 is nothing but 1 here. Right? So now whatever are the values you have obtained are the coefficients for a square, a raised to 1, a raised to 0 and the remainder. So your quotient is 1a square plus 0 a raised to 1, 0 a raised to 0. That means it is nothing but a square. Remainder is 1. Right? Okay guys, let's go on further. See, let's observe something. When I divide x square minus 5x plus 6 with x minus 2. Okay, I can multiply with x. I will get x square minus 2x. Okay, subtract, I will get minus 3x plus 6. Minus 3 से multiply कर दो, you will get minus 3x plus 6. Subtract, you get the remainder 0. Okay, if you observe carefully, x square minus 5x plus 6 को हमने x minus 2 से divide किया. Okay, okay, what you are actually doing is you are dividing x square minus 5x plus 6 with its own factor, right? Now let's observe, ये x minus 2 basically 0 कब होता है? X minus 2 0 कब होगा when x equals to 2? Now, when you substitute x equals to 2 in the given equation, x square minus 5x plus 6, let's calculate the value of the expression. Okay, 2 square minus 5 into 2 plus 6, whoa, we get a 0, right? Okay, and this is bound to happen, right? Because x square minus 5x plus 6 hai. Okay, if you're dividing it with x minus 2, we saw that the quotient is x minus 3, right? Okay, that means you're basically dividing a number by its own factor, right? Okay, so if you divide x square minus 5x plus 6 by its own factor x minus 2, okay, you can imagine this by putting, you can imagine this as putting the divisor as 0. Okay, when does that happen? That happens when x equals to 2. And when you substitute that, the expression comes out to be equal to 0. Okay, but let's observe, when I divide x square minus 5x plus 6, okay, I will multiply by x. I'll have x square minus x, so minus 4x plus 6. Again, I multiply by minus 4. Okay, I will have a remainder which is 2. Okay, now when I substitute x square minus 5x plus 6 mein, x is equal to 1. Okay, let's see what value I get. The value I will get is simply equal to 2. The remainder here, right? 2. Same, right? Okay, and it's bound to happen, right? Because when you divide x square minus 5x plus 6 with x minus 1 and x minus 4, you get an extra remainder 2, right? Okay, so यहाँ से हम दो चीज सीखते हैं. So guys, in f of x equals to x square minus 5x plus 6, when x minus 2 was a factor as we saw, then f of 2 came out to be equal to 0, right? When you substitute x equals to 2 in the given expression, x square minus 5x plus 6, you get the value of the expression as 0, right? This is the first thing to observe. The second thing to observe is whenever we took x square minus 5x plus 6 and x minus 1 is not a factor, you observed, right? So when you substitute x equals to 1 in the given equation, you got the value 2, which is the remainder obtained, isn't it? So combining these two into one result, we can say that if f of x is an algebraic function, then f of a is equal to 0 will imply that x minus a will be a factor of the given function. Otherwise, you get the remainder when f of x is divided by x minus a. Find the quotient and remainder when a cube plus a square plus 1 is divided by a plus 1. Deja vu? Yes, it's the same question that we began with. Okay. So by the remainder theorem, we first put a plus 1 is equal to 0. A plus 1 equal to 0 kab hoga? When a is equal to minus 1. So we substitute minus 1 in the given expression, a cube plus a square plus 1, and we check its value. The value is 1. Okay. But now we have obtained the remainder. What about the quotient? Guys, observe that when I divide 15 with 7, I get 7 2s are 14. The remainder is 1. This tells us what? 15 में अगर हम 1 subtract करेंगे, I'll get a multiple of 7, right? Same way, if I'm getting a 1, when I divide the expression with a plus 1, that tells us what? From the expression a cube plus a square plus 1, अगर मैंने 1 subtract कर दिया, I will get a multiple of a plus 1, right? Let's observe this. I get a cube plus a square. Okay, between these two, you can take an a square common. This is nothing but your quotient, right? A plus 1 is a divisor. Very clearly. So you've got the quotient as a square. Let's solve a couple of more questions based on this, guys. Okay. Find the when p raised to 4 minus p cube plus p square minus 1 is divided by p minus 1. Find the quotient and remainder. I want you to just pause the video and try it out. Okay, let's solve this. So when we put p minus 1 as 0 or p is equal to 1 in the given expression, we get 0. That means the given expression p raised to 4 minus p cube plus p square minus 1 is basically a multiple of p minus 1, right? Or basically p minus 1 is a factor, right? What do we do next? Okay, if 0 is a remainder, we try to factorize this particular expression directly in the form of p minus 1. Let's see how we do that. Okay, between the first two terms, you can take a p cube common, and the last two terms are basically a square minus b square, can be written as a plus b into a minus b. Okay, doing that, you can take p minus 1 common from both the terms, right? When you take p minus 1 common, what is left is p cube plus p plus 1, your quotient.